Hey everybody, I'm Oscar Spencer, and my talk today is unlocking the power of reactivity with Vue 3. And in this talk, I'm going to give you the lowdown on reactivity in Vue 3, and then at the end, I'm going to do a little demo of an untraditional way of using Vue. Hope you like it, stick around to the end, and let's get going. So first up, what even is reactivity, right? If you research reactive programming on Wikipedia, you'll see a bunch of information about data streams and asynchronous programming. And while that's all fine and dandy, what's really important is the simple definition here. It's just a style of programming that allows us to declaratively react to changes, right? And the classic example of this is the spreadsheet example. I absolutely love this example. I think it's a fantastic way of seeing exactly what this means, right? And this is an example that's even on the Vue website, like they believe in it too. So if you take a look at this spreadsheet, in column A, we've got the value 5. In column B, we've got the value 7. Now, the important declarative part about this is in column C, we've declared it to be the sum of the value in column A and the value in column B. That's what's important here. So when we update the value in column B to be 19, the value in column C automatically updates to be 24. And this is a very powerful thing, right? We don't have to explicitly go and say, hey, whenever the value in column A or the value in column B updates, go and update C. We don't have to do that. We can just say, hey, C is always the sum of these two things. And that's very powerful. Now in JavaScript, this doesn't really work out of the box, right? If you take a look at this code example here, we say let x be 5, let y be 7, and let sum be the addition of x and y. If you were to console.log sum, you're going to get 12. Right? And if we update y to be 19 and you console.log it again, you're still going to get 12, right? And that's fine. JavaScript's doing its thing. That's JavaScript. It's normal. But it's not reactive. And what we want is some reactivity in our lives, right? And that's the difference between imperative programming versus declarative programming, right? So take a look at this code sample on the right here. We still got the same x is 5 and y is 7, and the sum is the addition of x and y, but we've added an update y function. And this update y function takes a value, and with that value, it sets y to be that value, and at the same time, it sets sum to be, again, the addition of x and y. That's cool. That's fine. But anytime you want to update the value of y, you can't just set y to be a new number. You've got to call this update y function. And that can be a little bit cumbersome. It's not necessarily the best API, but it does work, right? And if we take a look again at the bottom, we've got this declarative style where we didn't have to do anything. If we want to access A or we want to change A, it'll update C always in a spreadsheet. That's just how it works, right? And so how could we get some reactivity in JavaScript? On the Vue website, they've got a great example where they say, here are the 3 steps to making something reactive. The first step, we got to detect when there's a change in one of the values. The second step, we got to track the function that changed that value. And the third step, we got to trigger the function so it can update the final value. So let's take a look at how we could do this. And in JavaScript, ES6 gave us proxies. And if you've never used proxies before, you're in for an absolute treat. So with proxies in JavaScript, we can use them to wrap an object. And so if you take a look here, you've got your user code that's normally accessing in a regular object. And with a proxy, we can intercept everything that happens. Whether you're getting a value, you're setting a value, we can take a look at it. And we do this through handlers. So if you take a look at this code on the right, we got a person. Good old Bob Smith, 35, doing his thing. He's chilling, right? But what's important here is the handler. And we got this get handler, and in fact in JavaScript, we call all these different actions that happen to an object that we define in the handler, we call them traps, right? Because you're sort of trapping the action that happens and injecting your own code. And so here, a get action, this is like dot access on an object. If you say person.name, this is going to be the function that gets called. And in this case, we're just returning the value that's associated with this object. So if you say person.name, you're going to get Bob Smith. The way that we actually get that proxy is by using the proxy constructors. We say new proxy, we pass in our person object, and we give this handler. And boom, now anyone who's using our new proxy to object has to go through our code. So take a look at this example. We still got Bob, still chilling. But look at this handler. Now, specifically, when someone is accessing the age property, we're going to console.warn a message here. Or just like, hey, it's rude to ask somebody's age, but whatever, go about your day. And then at the end of that, we're still going to return value. So if you access any other property, we're just going to do the normal thing. But specifically, if you ask for the age property, we're going to console.warn this value. So if you take a look down here at the bottom, our console.logs, if you console.log person.name, you get Bob Smith. And if you console.log person.age, the moment we access age, we're actually getting that console.warn message. Now let me actually back up a second here. Notice that I use console.warn here instead of console.log. That's just because sometimes you gotta, let people know they gotta step off a little bit, right? But it's not really important, whatever. It's just jokes you tell yourself when you're in a room by yourself. It's fine. And setters. If you take a look here, we're doing something here when someone's trying to set the name property of an object. So in this case, we got our person object, and you're trying to set their name, but say you're trying to set it to null or the empty string. In this case, we don't want that. Instead, you're going to get anonymous, which I don't know that you'd use this in the real world, but something like this is a prime example of how we could use these things. We can say, hey, we're not going to actually set it to the value that you said. We're going to just set it to a completely different value. And if you're not trying to do set a name, we can just do the normal thing, right? Now, we got traps for all the different actions that can possibly happen to objects. So yeah, we have get and set, but maybe you're asking what key an object has. We've got a trap for that with the has trap, right? Maybe someone's defining new properties or deleting properties or trying to access keys on that object. We have traps for all of these so that way we can track whatever someone is trying to do to an object. So remember for a second our 3 steps to building reactivity. We got to detect when there's a change, we have to track the function that changes it, and we have to trigger that function so it can update the final value. How do we go about detecting a change? Well, conveniently, we don't actually have to do anything special for this. Whenever we're actually going to update a value, we have a proxy. The proxy is going to straight up say, hey, I'm going to run your code when this value is updated. So we don't have to do anything special to detect the change. It's just going to happen. And like this comment says, the best code is no code at all. Some of my best code has been absolutely no code. There's never a bug. It's amazing. But how do we go about tracking a function? This is where it gets a little bit interesting with you. So imagine you have some effect that's going to run, and you have access to this function. What's kind of interesting here is you can actually just say, hey, let's record every single property access when we run this function. So you can say, hey, we're going to start recording, and then we'll run your effect. When you get a value on any of the objects, this handler is going to get hit. And so here, we're tracking the object itself that gets accessed and which property. And then, if you look at the set action, the set trap, we can actually trigger any of the effects that rely on this value when you change it. So maybe you have a counter and it's set to 5, and when you got that value, we notice, hey, you depend on this value. And now whenever you set that value, we're going to trigger that function. All of a sudden, we've got a fully reactive system, right? We have everything that we need to get something reactive. And in fact, this yields a fantastic API, right? Because if you remember our code example from before, we had an update Y function, and no one wants to use the update Y function. You want to just access Y, right? And with this system, you can just use objects normally. You can access whatever values, you can change whatever values, but you can declare what effects you want to happen when these values change. And that's what makes it so powerful. How does this relate to Vue? Well, you have your Vue component and you have your data function. From your data function, you're returning an object. In this case, we've got the key foo value Vue, right? When you pass this object to Vue from your data function, Vue creates a proxy for it. Vue says, hey, you gave me this object, let me track all those changes for you, right? And in fact, if you have nested objects and whatnot, Vue does this recursively. You get proxies for everything. And this is how Vue works. This is how Vue's tracking everything. In fact, take a look at this diagram. Now, this diagram is from Vue 2, from the Vue 2 docs, but it's still completely relevant and still very, very important. The part that's particularly important is the watcher part in the upper right-hand side. Every component of Vue has a watcher instance, and that watcher is the thing that's tracking the dependencies. So basically, right before the render function is called, it says, hey, I'm going to track every single property that you access. And so your component gets rendered, and then every single time you access a value, it's calling that track function. It's realizing, hey, you depend on this value, you depend on this value, you depend on that value. And so then, whenever you change one of those values, when you set it to a new value, the watcher says, hey, I noticed you did that. And in fact, this component is completely invalid now, and we got to re-render it. So whenever you change one of those values, it re-renders. And that's how Vue works, right? We got those getters and setters in the data, and it just notifies the watcher, hey, boom, we got to change. It's pretty sweet. Now, back in Vue 2.6 is when vue.observable came out. But this is when Vue split out the reactivity stuff into its own module. So maybe you don't want to use it only with Vue, you want to use it somewhere else. Well, now you code it, right? In Vue 3, they decided to rename this. Instead of vue.observable, it's now vue.reactive. That's just to avoid a conflict with RxJS, which is a pretty sweet library, check that out. But yeah, it allows you to straight up say, hey, I want this object to be reactive. You don't have to go and do some weird hacks and anything. You can just straight up say, hey, I want a reactive object, and Vue will give that to you. Here's a Vuex-like state store. So if you look on the right side, we got this code where the state, this is where we're using vue.reactive to say, hey, we got the state object and we want it to be reactive. We've got some getters, got the foo, just return state.foo. We got some actions, set foo, it sets foo, and then we export them, right? And that looks exactly like Vuex. And if you look on the left side, we've got our Vue component, and it kind of looks a lot like using Vuex. But the important key difference here is we're not using vuex.map getters, not map state, not map methods, none of that, right? Because this object here is already reactive. So there's nothing special that we have to do to it. It's reactive. It's just going to work, right? So if you wanted to build your own Vuex, you totally could. Vuex is amazing, but maybe you've got some unique needs and you can do that. Here's a pretty cool example. So I don't know if you've ever used render functions in Vue before, but sometimes you've got some weird thing that you can't quite accomplish with a template. And so what we do in these situations is we write our own render functions. In fact, our templates in Vue always get compiled down to render functions for us automatically, but you can implement them yourselves. If you take a look at this template here in the top left, all we do is render two boxes, which, by the way, in my opinion, sickest Vue 3 feature is the fact that I can have multiple root elements in my templates. It's honestly a game changer. That's enough for me to upgrade to Vue 3, honestly. But yeah, anyway, getting back to it. In our script, we've got a state here. In this case, we have a color for box 1. We've declared that to be red. We've got a color for box 2. We've declared that to be blue. Let's take a look at the render function for box 1. If you're not familiar with vue.h, that was another breaking change in Vue, but most people weren't writing render functions, so it's not really a huge deal. But we use vue.h to create nodes, right? Nodes that are actually going to get rendered to the DOM. In this case, we create a div, we give it a class, we say, hey, this is box 1, and we say what its color is. In this case, it's red. We have a paragraph that just says that same information. box 1 color, in this case, still red. And then we give you a box to update the value in box 2. Now, this is this value box 2 color is linked to the second box. So when we update the value in this box, it should update the color of the second box because we have this reactive state. If we take a look at the second box, box 2 here, it's exactly the same deal, except when we update the value in its box, it should reactively update the color in the first box. Let's face it, view component. We got 2 components, box 1, box 2. No one really cares about my style, so it's whatever, but I tried really hard on these, but it's whatever, not gonna go over those. But yeah, let's update the value of box 2. It's set to blue right now, let's make it green. And yeah, it's reactive, right? It does this. Now, again, the important thing with render functions is they're not automatically reactive. If you want to make them reactive, you do have to have some sort of reactive state. And that's exactly what we get here with vue.reactive, right? If we take the second box and let's update it to purple. Boom, it's purple. And we're sort of good to go now. But yeah, that's sort of this example. This is like a very basic, hey, I've got some reactive state. I want these components to talk to each other. And that's how you do it. So, Vue 3's extensions of the reactivity module. Like I said, observable was renamed to reactive. There was a value called effect that was renamed to watch effect, which I'll go over in a second. We got refs now, computeds, and watch. It's all sort of amazing stuff. So you've seen so far that every time we make something reactive, it's an object. Objects are amazing. We love objects, but sometimes you have a single value that you want to make reactive, right? And in this case, we've got a lights on value. And it's just a reference to the value true. The lights are on, right? We can console.log lights on, and we get true. And we can set it to false, console.log it again, and now it's false. But that's pretty expected. And the important thing to note here is that we do have to access the underlying value in dot value. It's a little bit annoying, but if you sort of think about it, a ref is sort of just, it's another object because we can have our proxies, we can have our traps, so we can tell when you're actually updating those values. Computed. This one gets me hyped because with computed, we can now have standalone computed values outside of Vue components. And this is absolutely amazing because here we check if the lights are on, and if the lights are on, the message value will be the lights are on. And if the lights are off, the message value will be the lights are off. So now we've got a reactive value that we can just use. And if you think back to earlier when I was talking about, oh, JavaScript doesn't have this, and you say x plus y, like sum is x plus y, you could use this to make that behave the way that you expected. Sum could just be a computed value where it does this. Watch effect. This is an absolutely huge one. So watch effect allows us to register effects that run whenever dependencies on that effect change. So take a look here, look at this code. We've got a counter. It's a reactive object that just has one property called num, and that value is 0. And we've got this binding let current number, and we're gonna update that. And then we say watch effect. Current number is equal to counter.num. So when we run this program, Vue's gonna run that effect, and current number will be set to the current value of counter.num. And in fact, you see that on line 9 when we console.log current number. You get 0. But then when we increment counter.num, so that way it's not 0 anymore, it's 1, our effect gets run again automatically. And so if we console.log current number, we get 1. And this is huge because that means we can register arbitrary effects that are going to happen as data changes. And that's a very powerful API that lets us do way more than we imagine, even outside of the front end, right? And yeah, additionally, it's going to track way more than just when you're accessing a value. If you look here, we've got a watch effect. where we're taking the keys of an object. And we say object.keys of the map or whatever. But the important part here is the fact that Vue is smart enough to understand that, hey, if you access the keys of the object, that's a dependency and it should run again. And we can do that because we have all these different traps for our handlers that let us watch every single thing that happens to an object, which I think is pretty freaking neat. So watch. You've probably used watch with components before. What watch does is it lets you explicitly declare when an effect should run via functions or run directly. So if you've got a component and you have your watch, you can say, oh, check this value. Whenever this value changes, we're going to run this thing. This is exactly that, but in standalone form. And so it works two different ways. The first way is via function, where you can return a reactive value. In this case, we say const counter is, again, this reactive object with the value num. And yeah, we can just like return a function that accesses num. And then you get, as the first argument, that number. And the second argument, you get the old number. You do your thing. And then the second way is you can straight up just watch a ref. And you can get, again, the current value and the old value. And you can do what you got to do. Whatever you want to stick in there is going to work. So what are some possible uses of this reactivity module? Other front-end frameworks, right? If React was like, hey, we're tired of our reactivity stuff, we want to use Vue, they can npm install @vue/reactivity. It's going to work, right? Interactive animations. Imagine for a second you've got a stream of weather data and you want an animation to change. You don't have to do anything special. You can just register effects and say, oh, if it's raining, update this. If it's doing that, update that, and it's going to work. Notifications. This is a classic example. Something comes in, new data, effect. Boom, show a notification. Chat clients. If you wanted to, you could build a chat client completely out of effects. As someone sends a message, that triggers an effect, and it updates on a person's screen, right? But databases. Could we use Vue to build a database? I say yes. I'm going to show everyone my gorgeous code here. Please stand by. I got a setup here. And in this setup, we've got an AWS Lambda function. They're just out in the cloud somewhere. Doesn't matter. And this is the code for that. Like, literally does some like token stuff. No one cares. But more interestingly, this Lambda function, when it receives a request, if you tell it to tweet, I've got a Twitter account over here that will tweet something. If you tell it to yeet, it will yeet that tweet. It will delete it for you. Tweet something wrong, it's got your back. And yeah, literally it just hits the Twitter API, does this thing. Not terribly interesting. But what's really important is my database. Look at this sick database implementation. We import reactive, and our database is just a plain JavaScript array that we've made reactive. I think that's fantastic, right? We don't have to do anything special. We can just say, boom, our database is an array and it's reactive, and it's going to be reactive. It's going to work. But let's walk through our application code. So this is an application I have running on my computer. It's an Express app. We're using reactive and watch effect. I've got some effects to find another file here. We got tweet, yeet, create spreadsheet, white heat, some bittersweet. Like, we got lots of actions here. And we register our first two actions. We say, hey, here's an effect called tweet. Here's an effect called yeet. That's it. We just register them. We're done. And we got some routes. We have a route where you post a new user. It literally just adds a record to the database. We have a route where you delete a user. My backend code is amazing. We iterate through all the records. If the person's name is the same, we set the yeet property to be true. And we're all good, right? We have a patch route as well, which updates the values on a particular record. You can add a super user. Maybe you have a super user logging into your app, and when they come online, you want to go ahead and kick off some long-running task. In this case, it's like create some ginormous spreadsheet. And we got a purge action. That one's important. Yeah. Amazing API design. You never know when you gotta just have an endpoint where you delete everything in your database. And we got two effects for that. We have white heat and we got something bittersweet. So let's take a look at these effects themselves and see what's going on. So here, our first effect is tweet. As you can imagine, when the tweet action happens, we just post to the AWS Lambda job. And we say, hey, tweet, and say this person has joined the community. And the most important one, we want to yeet. When you want to yeet, we post and we give the operation, hey, you're going to yeet. Just delete this tweet, right? And we stored the tweet from the last time, so we can delete that. We have init create spreadsheet. In this particular case, we on-demand register an effect, right? You tell me what user you want me to register this effect for, and then we return a function. That's the effect that gets run. And if the user's online, we'll go ahead and generate that spreadsheet. The white heat effect. One of my favorites. Well, you know, when the database is empty, we just have a lot of fun. It's whatever. And then we have the something bittersweet effect, which I won't show you that now. But let me run through what happens when we actually use this. So here's Postman. And we're going to add a new user. This is my boy Joe. Let's post. Send. Created. Live demos. Let's refresh our Twitter account. And there's a new tweet. Joe has joined the community. What's amazing about this is the fact that we did not say, hey, send out a tweet when you push a new record. We just registered an effect. So we've got this beautiful separation of concerns where you don't have to explicitly say, hey, send out this tweet. You can just register an effect and as many effects as you want. So that's fantastic. Let's go back. We can delete Joe. We can yeet Joe. Send it. It says, okay. We come back. Let's refresh. And that tweet's gone. Joe was yeeted from existence, and there's no record of it on Twitter either because it's gone, right? Now let's post a new user, Sarah. She's not online. She just got a name. She's not online. But we can post that. Let's refresh the Twitter. Sarah's joined. That's good. But now, let's update Sarah. Let's set the online property to be true. So we'll send that. She's come online. Let's actually slide over to our app. And it says generating spreadsheet. Done. So boom. Sarah's come online. We generated that spreadsheet for her. And then that / purge endpoint, because you never know when you got to yeet your whole database. Let's send that. And if we go back over here, we got some white heat, and I imagine there's nothing left in the database. But if we refresh the Twitter account, there's a new tweet that says, thanks to everyone watching. So once again, thank you for watching my talk. My name is Oscar Spencer. I'm a software engineer at Tidelift. If you want to know how to get catalogs of known, good, amazing, secure, maintained open source software, hit me up. I can help you out with that. If you're interested in programming languages, I have a cool project called Grain that I've been working on for a little while. So follow me on Twitter, check me out on GitHub, and we'll go from there. Thank you very much for listening, and I'll see you next time.